when you are doing non-destructive microwave testing and the probe begins to wobble or shake due to a curved surface, what is to be done then? If you want to know, then you are right here. The standard contact surface of a handheld microwave probe is planar. When it is attached to the planar surface of a device under test, it can evenly be moved across it. But when it is attached to a curved surface like this, it tends to wobble and create irregular and undefined signals. To avoid this, special adapters are helpful. We will see 4 examples in the following. This is a GRP pipe of 50 millimeter diameter and 5 millimeter wall thickness. I have placed a small piece of GRP inside to simulate an artificial defect. And this is the adapter which I had mentioned according to the convex surface of the part. This is the surface cylindrical concave. It well fits onto the surface of the part and can be moved in both directions. The adapter has a curvature of half the part diameter, that is 25 millimeter. And I can easily slide the adapter onto the flange of the probe. Now I place the handheld probe with adapter onto the part, and I move it across the region where the defect is, and I can very clearly, without any wobbling, detect it here at this position. Back and forth, and also actually in this second example I attach a band of 8 millimeter wall thickness to the pipe. The defect is still inside the pipe. So at this cylindrical region, there is a total wall thickness of 8 plus 5 equals 30 millimeter over the defect. And the diameter of this cylindrical part here is 64 millimeter. And therefore, I use a new adapter, which is concave cylindrical with a curvature radius of 32, which is half of 64 millimeters. I place the probe with the cylindrical adapter on the cylindrical part of the band. I'm searching for the defect. Here we have it. Here the position of the defect. The signal is rather small, and it would be covered by the irregular signal if the probe would wobble. Yeah. That was a rather weak signal, near to the limit of detectability. Now in the third example, I have placed the defect inside the wall of the band, and here it is on the outer side of the band. The surface here is more complicated. It is two-dimensional convex. Well, and a good attempt to avoid the wobbling when testing with a handheld system is the use of such a spherical adapter. I place the probe with the spherical adapter onto the surface, and I move it across the region where the defect is, and we see a significant indication. And that without any wobbling. Let's come to the fourth example. Now I have placed the small defect again inside the wall of the band, but also near to the inside of the bending region. That means we have it located approximately here, and that is a complicated region because the surface here is concave in axial direction and convex in circumferential direction. So it is like a saddle, and therefore also the adapter is made of such a saddle-like structure, which well fits into this region and can be moved slightly in circumferential direction and also in axial direction. I place the probe with the saddle-like adapter on the device under test. I move it. I see a deflection, maximum deflection. It goes back, and I move it back. And here we have the maximum. That is the position of the defect. And the signal goes back. We have seen that appropriate adapters are very useful to avoid shaking and wobbling when testing on non-planar surfaces. The adapters can be made to tight fit to the surface of regions to be tested. The adapters can be made rather fast by use of additive manufacturing and surface metallizing, and they can be replaced quickly according to current needs. The probes with and without adapters are used in handheld testing, but can also be used in automatic and robotic test systems. So far for today. Thank you for watching. See you next time. Goodbye.